Hey there, chemistry students. This is Miss Relark. This is Vodcast 3.2, where we're going to learn how to name ionic compounds and how to write the formula for an ionic compound. Oh, it doesn't want to change. What is going on? It doesn't like me. Look at that. It's not changing. All right, hold on. All right, got it going. Okay, so ionic compounds. Remember, how do you know it's an ionic compound? You know it's an ionic compound if it has a metal listed first, either in the formula or in the name, or if it has ammonium listed first. Okay, so ions and formulas. By predicting the formation of ions or their charges, you can determine the formula of an ionic compound. Okay, so what in the world does that mean? Well, we've done this in class already, so we're going to show you an easier way to do this. So what compound would form from calcium and oxygen combined together? Well, in class we said if calcium makes a positive 2 charge and oxygen makes a negative 2 charge, there's a 1-to-1 ratio, so it would make CaO. It doesn't want to work. Look at that. Oh, CaO, because we have 1 calcium for every 1 oxygen. Well, an easier way to do that is what we call the crisscross method. And rather than having to figure out how many of each you need, you just write down, step 1, write the charges of the ions. So calcium with a positive 2 and oxygen with a negative 2. Cross down your charges. Now, when you cross down your charges, all you're doing is crossing down the number. You're taking the absolute value and crossing it down. You're not pulling down any of the charges because we're not concerned with charges anymore. Okay, so the 2 comes down here, this 2 comes down here, and then we're going to rewrite this. When we rewrite this, we rewrite it with Ca2O2. But look, step 3 says, guess what? If it's an ionic compound, it has to be simplified. So we can take these 2 here, and we can pull out the greatest common factor. I think that's the one. I can't remember if it's greatest common factor or least common multiple. Whatever. You know what I mean. We can pull a 2 out of each of those, and when we simplify that down, it becomes CaO. All right. So here are some examples. I'm going to do 3 of them with you, and then I want you to try the other 3 on your own. All right, so let's say we'll do A, we'll do E, and we'll do F. Okay. All right, aluminum. Aluminum has a +3 charge. How do we know? Because it's in group 13. And bromine has a -1 charge. How do we know? Because it's in group 17. All right. When we take these subscripts and we cross them down, or take these charges and cross them down, the 3 goes there and the 1 goes there. Rewrite this as Al1Br3. Do I need to keep the 1? No, we don't write 1s. We just say that it's implied. Do I need to keep the 3? Yes. Can I simplify these? No. If you ever have a number 1 as a subscript, you can't simplify it anymore. So the formula would be AlBr3. All right, copper. Copper's in that weird group that can make +or -4. Well, copper is a negative ion, or it's a non-metal, so it's going to make a negative ion, so it makes a -4 charge. And then chlorine is going to, but you said, Ms. Ruark, it's a non-metal and it makes a negative. And here we have a -1, and we can't have a negative and a negative, so guess what? Copper in this case will end up with a +4 charge. It's okay, copper can swing both ways. All right, so we're going to take that 4 and we're going to cross it down. We're going to take that 1, we're going to cross it down, and we end up with C1Cl4. All right, can I simplify it? No. Do I need to write the 1? No. So we write it as CCl4. All right, for the last one, we have Cu and O. Well, copper is one of those weird ones in the middle. It can make a +1 charge, and it can make a +2 charge. So if we hit copper with a +1 charge and oxygen, it has a -2 charge. When we cross those down, we would end up with Cu2O1. Does it simplify? No, but we can get rid of the 1 and we would have Cu2O. Well, what about here with a +2 charge? If we had copper with a +2 and oxygen with a -2, when we cross those down, we would end up with Cu2O2. Can it simplify? It sure can, so that would simplify down to CuO. All right, I want you to do the other 3 and make sure you have them done before you come into class. Okay, naming ionic compounds. So there are some rules that we follow. The names of ionic compounds are always going to end in IDE. We always put "ide" at the end of our compound. So that always goes on the second element, or the non-metal. The non-metal always gets the IDE ending. All right, the metal, or the positive ion, always comes first. So we don't write it as, if we had NaCl, we wouldn't write it as chlorine sodide. No. The nonmetal is the one that changes the end, and we always name it first, second. So the positive comes first, the negative comes second, so it would be sodium chloride. And we never capitalize it unless we're starting a sentence with the name. All right, so some examples here. We have calcium and iodine. So this would be calcium iodide. Okay, here we have ONMG. OMG. Okay, sorry. Couldn't help myself. Okay, which one's positive, which one's negative? Well, oxygen's going to make a -2, which means it has to go second. Magnesium makes a +2, which means it has to go first. Positive always goes first, so magnesium, and then oxygen becomes oxide. Now, here's a good question that always comes up. How do you know how to change the end of the name? Well, you'll usually take the root or the first syllable or two of the name. So if it's nitrogen, it becomes nitride. If it's carbon, it becomes carbide. If it's phosphorus, it becomes phosphide. If it's sulfur, it becomes sulfide. Chlorine becomes chloride. Bromine becomes bromide. I think you get the point. All right, so Na with S. Na makes a positive charge and S makes a negative, so sodium comes first. It would be sodium, and then from sulfur, we drop the end and we add IDE, so it becomes sodium sulfide. All right, this should be a piece of cake, right? Okay. All right, well, what if we have transition metals? There's a couple different ways that you can name a transition metal. There's the new way and there's the old way. The new way, or the standard naming, you're going to take the anion, which is whatever the negative ion is. You're going to change the end of it to IDE if it's an element. The charge of the metal will be indicated in parentheses using Roman numerals. And just in case you don't know your Roman numerals, there's 1, there's 2, there's 3, woo, there's 4, there's 5, there's 6. You don't need more than that. All right, so copper with a +1 charge would be copper 1, and copper with a +2 charge would be copper 2. That was hard, wasn't it? I know. Okay, the number refers to the charge on the ion, not the number of atoms. All right, so for example, to write the names and the formulas for the following compounds. If we had copper with a +2 charge and chlorine, to write the formula, we cross those down, has a -1 charge. It would be CuCl2, and this would be copper 2 chloride. Okay, here, cobalt with a +2 and chlorine has a -1, so it would be CoCl2, and it would be cobalt 2 chloride. That's pretty easy, right? All right, Zn with a +2 charge and chlorine with a -1 charge, so it would be ZnCl2, and oops, you would write it as zinc 2 chloride. Now, funny thing about zinc is that it only makes a +2 charge, so you don't have to include the Roman numerals. If you do, it's not a big deal. You're not going to get chastised for it. We're not going to flunk you. You'll be okay. All right, and then for the mercury. Mercury can have a +2 charge, and mercury can also have a +1 charge. Now, you're like, that's not a +1, it's a +2. Well, we say it's a +1 because there's 2 of them there. Okay, and then sulfur can make a -2 charge. So I want you to try those and bring them in. I might give you extra credit for it. I don't know. We'll see. Okay, the classical or the old way of naming a transition metal ionic compound. Again, you're going to change the ending of it to IDE. The metal is named with its Latin or English root, and it ends in either OUS or IC to show the charge. IC means that it has a higher charge than OUS. So copper would be cuprous, Copper 1 would be cuprous, and copper 2 would be cupric. Okay, now here's a chart of them. They're also in your vodcast. I'm showing you this so that you would be familiar with it and you would actually see it, but I'm not requiring you to learn it. If we decide to make sure that you do know a little bit of it, I'll tell you about it in class, but I don't think we're going to have to worry about that. So if you want to try these, go for it. If not, move along. Okay, we're going to eventually come into these nasty little boogers, I love them actually, called polyatomic ions. And it's a group of atoms that are bonded together that have a charge. Look, I just said that. Group of atoms can also have a charge. So polyatomic ions, poly meaning many, atomic meaning atoms, are ions or groups of atoms that interact as a single unit that have a charge, positive or negative. All right, so examples of those would be OH with a -1 charge, this is hydroxide. SO4 with a -2, that's sulfate. Okay, here is the formula for an ionic compound with a polyatomic ion, and we know it's ionic because barium is a metal. So we would name this barium and then phosphate. The end of the polyatomic ion does not change. You do not change the ending of a polyatomic ion. You only change the ending of a non-metal. All right, so naming the following compounds with polyatomic ions, we would name calcium, and because it's not a transition metal, we just name it. We don't need Roman numerals. And then OH is hydroxide. Now, you do have a list of some of these on your periodic table, but then some of them will also be provided for you. All right, NH4 I showed y'all was ammonium. Okay, so this would be ammonium. And then NO3 would be nitrate. And we don't change the end of it, so it stays just like that. Okay, copper sulfate right here, but copper, guess what, is one of those transition metals that you have to show its charge. So this would actually be copper 2 sulfate. Okay, now the question is, how in the world did you know that, Mr. Dark? Well, sulfate, all of this right here, has a -2 charge because it's a polyatomic ion. And if it's a 1-to-1 ratio, this has to have a +2 charge. Don't worry. If you didn't get that, we will do so much practice over this in class that you are going to be able to do this in your sleep. All right. And then on this one, we have cobalt 3 carbonate. Right? And again, we're going to practice this so much that you are going to be able to do this in your sleep. So don't freak out if you don't know how to do it yet. Okay, writing formulas from names. So how do we do that? Well, we identify the ions and I want to say charges, but I think that's actually wrong, so we'll come back to that. So we're going to cross up. Nope, sorry, cross down. Yeah, that was right. Cross down the charges to write the formula, and then use parentheses around polyatomic ions because that's a family, it's a unit, and we want it to stay together. All right, so sodium chlorate. We'll do a couple of these, and then I want you to do the rest of them on your own. So sodium is Na with a +1 charge, and chlorate is a polyatomic ion. Well, it is ClO3 with a -1 charge. Before we cross those down, okay, before we cross these ones down, we need to put this entire polyatomic ion in what I like to refer to as a force field. What do force fields do? They keep things inside of it safe, and they keep things out. All right, so when I cross this down, don't get lazy and forget your force field. Put it up. Okay, when we cross this one down, the one comes outside. This one goes outside. So we rewrite it as Na1, ClO3, 1. Do we write ones? No. So we take the ones out, and it would be NaClO3. Well, since there's nothing behind that parentheses, do I have to have it? Not really. Can I keep it? Sure. It's not wrong. There you go. Oh, not bad, right? Okay, ferrous, let's change that. That would be iron 2. Okay, so if iron 2 means that it's iron with a +2 charge. And oxide is oxygen with a -2 charge. We want to cross those down, so we end up with Fe2O2. And can we simplify it? We sure can. And for those of you who study Spanish, that element is very ugly. All right, last one, ammonium chloride. Ammonium is NH4 with a +1. Chloride is a -1. When we cross those down, we've got NH4 in parentheses with a 1, Cl1. Do we have to write that? No, so we put NH4CO. I think that's it. I'm running out of time.